Hello everybody and welcome back. Welcome back indeed. We're looking at question 3 here on our Manitoba Math Contest. We got an A part and a B part. Question 3A. How many ordered triples, so the order A, B, C matters, of positive integers can be formed so that A times B times C is 12? For example, one such triple is 2, 2, 3. But a different one would be 2, 3, 2, because the order matters, not just how many 2s and how many 3s and such there are. Okay? Now this is kind of interesting, because with a triple, and they give us a good example, if you've got two numbers the same, and then a third number that's different, that can be rearranged 3 ways. So it could be x, x, y, or it could be x, y, x, or it could be y, x, x. And the order here does matter. Just like if you had 3 the same, you can only arrange them one way. Now, if I've got 3 different things that multiply to, in this case, 12, you can get 6 different ways to rearrange them. Now, the reason I'm bothering to point this out is because I just want to sort of calculate products of numbers that give you 12, and then say, all right, this set would give you 3, this set would give you 6. It makes it a lot easier to add things up. So I do this sort of work ahead of time. Okay? We don't need to worry about if you had 3 the same, because 12 is not a perfect cube. But if we were looking at 3 numbers that multiply to 64, x, x, x can only be rearranged one way. Anyway. Now, if I'm making 12 as my ABC, how can you make 12? Well, what I'm going to do is I'm going to say, well, what if A were 12? Then B and C have to multiply to be 1. But they're positive integers, so B and C sort of have to be 1. So that gives me 12, 1, and 1, and that's 1 different, 2 the same. There's going to be 3 ways with a 12, a 1, and a 1. 3 ordered pairs, or ordered triples. What if A were 6? Well, then B times C has to be 2. But B and C are still positive integers. 2 is a prime, so you're going to be left with one of them being 2, the other one has to be 1. But that's 3 different numbers, so I don't need to do all the rearranging stuff. That's 6 ordered triples. What if A were 4? And I'm just running through the factors of 12 in a particular order so I don't miss anything. Well, then B and C would have to be multiplied to 3 to make the rest of the 12. But again, it's prime, so one of these numbers is going to have to be 3, the other one's going to have to be 1. 3 different numbers, got to be 6 different ways. Now, what if A were 3? Well, then B and C have to multiply to be 4. So you could have one of them is 4 and one of them is 1. And you realize, oh, we've already done that. So don't double count things. Or you could have them both be 2s. All right? And then, well, that's going to be 3, 2, 2. And there's 3 ways to do that. And this should be it. It should be 18, I believe. Because I've been sort of careful to keep A as the largest number. You notice when B became bigger than A, we sort of reverted to a previous case. Now you can try A is 2, and then B and C will have to be 6. So you could have B is 6, C is 1, already done. Or you could have B is 3, and C is 2, already done. It doesn't really need to be done. Or A is 1, well, then you go B is 12, or B is 6, but we've already done those cases. So you just want to keep A bigger than B and C, and then let your previous math do the rearranging for you. So it should be 18 ways. If you wanted to, I mean, 18 is not so bad that you could write them all out, but I think it's better to maybe make the observation here and then have a plan and say, you know, let's make it so A is greater than or equal to B, greater than or equal to C, and be very methodical in what you're doing. Okay? I think that'd be a perfect way to get full marks there. Okay, so B. Prove that there is no 10-digit prime number which uses every decimal digit exactly once. Okay, so it'd have to be 10 digits, and you'd need to use the digits 0, 1, 2, 3, 4, 6, 7, 8, 9. And that's it. So some order, but I mean, there's going to be 10 factorial, which is a big number off the top of my head. 36. It's 36. Yeah, 3628800. That's a lot of different rearrangements of these letters or these characters, and so there's got to be some nice way of showing that nope, you can't do it no matter how you arrange it. And it's interesting that they ask us about all the single digits. One's there, two's there, three. We use every single digit just once. Obviously, the 0 it can't be leading, but that's not really going to impact anything. So you might notice, as I'm about to point out, that 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 is 45. So for such a prime, the sum of its digits is 45. Okay, big deal, who cares? But there's a nice rule that says if your sum of digits is a multiple of 3 or a multiple of 9, then the number you're talking about is a multiple of 3 or a multiple of 9, depending which one you want to work with. Okay? So there might actually be a way to do this if you just use the first, if you use 0 through 8. But by talking about all of them, we actually get this nice little sum of 45. So since, I'll just do 3, but you can do 9. I don't know what they've got in their solutions, but I assume it's a similar argument. So since 3 divides 45, our divisibility rules, and these are good things to know for math contest, divisibility rules that tell us any number using all 10 digits exactly once is a multiple of 3. So such a number cannot be prime. In fact, you know what? I'm gonna change it to the, because then you could say, well, what if it was 3 exactly? 3 is a prime, and that's true. But 3 doesn't have a digital. 3 doesn't use all the digits. But I think if I just say 9. There's no prime that is a multiple of 9, where there is technically one prime that is a multiple of 3. So to avoid having to write something about that, I'll just say that. Okay. So sum of the digits, multiple of 9. So the digits, the number that I make with these digits must be a multiple of 9, and therefore it cannot be a prime number. Nice little divisibility rule argument there. Okay, so that's question number 3 all taken care of. Up next, question number 4. Thank you guys so much for watching. If you want to stay up to date, feel free to subscribe to the channel. If you ever have a different way to do a question, a faster way, or just an interesting way, you know, maybe you did a geometric construction when I did some algebra or something like that, feel free to leave it down below. I always like learning new ways to do questions. But I'll see you for question 4 next time.